A PCB is an electrical system with multiple power supply voltages. If the required power isn't delivered to the IC or components due to PDN noise, it might lead to system failure. Using Sigrity PowerSI, you can easily identify coupling issues, power and ground fluctuations, and design areas which aren't meeting target voltages. The power integrity of your design can be easily regulated if you can control the PDN noise. By managing crosstalk or interference between signals, defining the stack of materials, and using decoupling capacitors, you can maintain PDN impedance. Within the stackup, you can also specify the conductivity of signal layers as a function of temperature. When a signal travels across the reference plane, it passes through a gap or void. Electromagnetic effects of these voids are accountable above a threshold value. Defining void settings gives you more accurate results with respect to power integrity. In this design, we want to analyze the parallel bus DDR interface. Select the required power, ground, and DDR bus signals from the net manager. There should be enough spacing between signals to avoid coupling, which might impact power signal stability. Easily define the minimum coupling percentage between the signals. There will be a red flag if coupling exceeds a specified value. Decoupling capacitors play an important role in controlling PDN impedance. By defining the appropriate value and number of decoupling capacitors, it's easy to keep the PDN impedance below or equal to the target impedance over a wide range of frequencies. For generating the S-parameter model of the power-aware parallel bus, define ports for signal and power nets at the driver, receiver, and power source in the design. After defining all the major parameters in the design, the last step is to set up simulation parameters. Easily define network parameters, simulation frequency, and the start simulation. Once the simulation completes, S parameters are generated for each signal in the parallel bus interface. Easily review the return loss of the power plane. You can also review the insertion loss on the signals. The graphs for all the analyzed signals give you an accurate insight of the design performance for the selected areas. With Sigrity PowerSI, it's easy to maintain the power integrity of your design by monitoring the PDN noise.